Okay, now let's go over some safety features that one can add onto a machine. First one I'm going to show you is a door interlock. Basically, there's a locking mechanism that once the operator closes the door, it makes sure that the locking mechanism is active, and it will only be released as long as the program isn't running or spindle isn't moving. But once that uh, program is told to run and the doors are closed, then it will energize the mechanism to lock it. Now, granted, there are some out there that lock it, and then there are others that the moment you close the door, they will be locked, and in order to release it or open the door, then you have to tell it to unlock it. Depending on whichever mechanism you're using, you just need to make sure that the PLC program is created or the logic is in there, works for that particular item that you're using. Now, rather than create one, because I've already done that before, I'm just going to open it up and show you what the logic is and go through it. So like that, one can easily add or implement that onto their existing PLC program if they ever want. Typically on that, you have 2 inputs and 1 output. The 2 inputs is there's a door closed, so like that you know that the door is in fact closed, and then there's a door locked, because even though you close the door might not be locked, so you want to make sure that it's locked. And depending on the mechanism that you're using, if you have to turn the output on that locks it, you need to make sure that you see that the door locked input is in the correct state before you can continue on with running your program or turning your spindle on. All right. So let's go ahead and take a look at the PLC program that I ended up writing. All right. And on here, you will see that we've got 2 inputs, a door closed and a door locked, and then we have 1 output. And on this one, we have the output that's door unlock out, which means that once that output is turned on, it will actually de-energize or unlock that mechanism, which allows you to open the door. Okay, so if we just end up going ahead and searching, we will see that this logic is basically tied to the door interlock stage. Right? Another thing too on here is that the Centroid software already has a somewhat of a feature built down there where it's looking at parameter 85, and that parameter, the value of that parameter, tells the control which input the door closed input is on. Now this is on the door closed. This doesn't have anything to do with the door interlock. But if that parameter is a non-zero value, then what the Centroid software does is that once that door closed input is not set, it will actually limit the feed rate that the axis can move to slow jog rate. And then, of course, once the doors are closed, then it allows you to go fast and rapid moves. But until then, it won't. So what this PLC program did, or what I ended up doing, was I also tied in to look at that same value. And as long as that value was set, then I would go ahead and set my door interlock stage. But if that value was set to 0, which means that there was no door closed input wired in, there's no point in having the stage on, because like I said before, your PLC program runs at about 50 times a second. And if you can speed it up by just turning off various stages. So at that point, it's like, why even bother going through all the individual logic and just speed it up a little? So that's what this one is doing, is saying that if it's not equal, if that parameter value is not equal to 0, then that means that it is a valid input, and then I am going to set this memory bit, and I am going to set this door interlock stage. But if it's not, then I'm going to reset this, and which means I'm bypassing it. And as you can see here, I'm setting this, which means that I'm going to turn this output on. And that's because if I don't have an input defined, which most likely means that if by any chance there happened to be a door lock, I don't want anything to lock it out, because I want to make sure that they're still able to open the door. Now, of course, if someone went in there and they wanted to bypass the thing, there's nothing that we can end up doing. But looking at that parameter, if they have it set to a 0, then that means that they don't have a door closed, so they don't want the software to do anything if that door is open. So that's why we just go in there and we set it. Now, if this was the output had to be a door lock output, clearly I wouldn't be setting that, because then that means that my output would always be on to lock it. I would probably have it reset the door lock outputs like that. That output never gets turned on. All right, so let's go ahead into the door lock stage. Let's just find it. All right. And here is where we have our door interlock logic on here. All right. First line of logic is basically, of course, looking at the door closed input. This is also, and it's doing an exclusive OR with this term. This here was something that was used in the past, where if something was normally open, we would actually set a bit in the parameter, which was parameter 178, that would actually tell it, or tell the control, that the input is going to be used in normally open rather than normally closed. Well, since then, we came up with that very easily and simplified way of inverting an input just by hitting Control-Alt-I in the PLC diagnostic menu. But prior to that, we didn't have that capability, so what we would end up doing is that we would have that input, and we would exclusive OR with a bit in the with the bit of the parameter. And of course, that bit was set if that particular input was supposed to be normally open. So we have that condition and the probe detect input and an aux13 key and that OTC override. So if either of those buttons were pressed, we would go ahead and set this override memory bit, which means that yes, we're overriding this, so it doesn't have to engage. And then, of course, we have the inverse that's saying if that input was not in the right state and there was no probe detect or your e-stop, then we would reset that override stage. Okay. Then we go into the logic. That's basically going to place the system into a slow jog mode. If they were trying to run a job or going into MDI, and the door was actually open while they were trying to do that. So we, of course, we add the logic. We say, all right, if you're not, program running or in the MDI mode, and your interlock mode is being set, which of course we set that based on that parameter value 85, and the door isn't being set, and you're not an override, then you go ahead and you make sure that you put it into this slow jog mode. All right. Then we also have the logic here that pretty much controls the display of a message that says that if you're trying to run a program and that door is actually open, we put the thing into a little, it's not really a fault state, but more of a pause state, where we just throw up a message saying, hey, your door is open and we need to close it in order to run the program. That's why on here we're not setting any kind of a fault. We're actually just putting the system into a feed hold state, and we're going to be displaying this message that's going to tell the operator saying, hey, your door is open and needs to be closed. All right. Then we also have logic in here that's pretty much turning your door unlock output on and off. And of course, if you're not running a program and the 0 speed, which of course the 0 speed is an input, typically comes from the inverter that tells us whether the spindle is spinning. But if those conditions are met, then of course you turn that door unlock output on. And of course, the opposite is also true, that if those conditions aren't met, then you're going to turn that output on, because you want that to actually be engaged. So of course, if once you're done running a program, you want that output to be on, so it releases the output so you can open it, and of course, as long as your spindle is not spinning. And if you are running a program and you've got that interlock mode being set, then of course we reset that so like that. Once it's closed, that thing has to be locked. Okay. Then on this next couple lines of logic, we pretty much just have a timer delay where once you end up getting this, we're setting a timer, and then of course if that timer expires, then we're saying okay, well, the door wasn't locked, and we're putting the thing into a SV stop mode. All right, and that's your typical door interlock stage, and like I said, it just needs this entire stage put in plus the few lines of logic if you were looking at the parameter 85. Now, of course, if you didn't have the door unlock and you had the door lock output, so you would turn the thing on, you can use this exact same code and logic. The only difference is that your nomenclature would now say door lock out, and then where it says set, you're now going to replace that with the reset. So this one would be reset, and this one would be set. Okay. Now let's also add another part of the safety thing where, let's say I've seen some people have a light bar. And so they have a light bar that gets set, and they want to make sure that no one puts their hands in inside the machine, so like that, safety reasons, don't want to get something cut off. Typically, I've seen a lot of punch presses that might have a light bar, so like that, it makes sure that the operator doesn't have their hands anywhere near the punch before they go ahead and start that. All right. So what I'm going to do is close out of that, go back to the PLC program that we've been writing, and what I'm going to do is add a light bar. So let's go ahead, go my inputs. Let's go ahead and pick rotary table home. All right, let me just first find it, make sure that it's not being used in the PLC program. I can see here, this is the only spot that it's being used. It's just defining it as. So there is no logic in there. So this is perfect. So I'm going to use input 7 to say that's my light bar. Okay. It might be a light bar. I don't know if that's the right terminology, or it might be a light beam. Essentially, what this thing does is it just sends a ray or a curtain. Oh, maybe that's what it is. A light curtain. That's a curtain on there that if there's an object that breaks that curtain, it'll essentially stop the system, put the state into a false state, and also what I'm going to do is I'm going to have logic that will prevent anyone from running anything. Okay, so first thing I'm going to do is I'm going to define my input light curtain. Okay, and like I said, the previous one wasn't being used, so this is perfect one that I can use and toggle it to input number 7. And of course, I have my all-in-one DC with the switch box, so I can easily flip the switch for light 7 and verify that my logic is in fact working. So now I'm going to go into the main stage to add my logic. All right. So now let's go ahead and let's add the logic to everything that I was doing before. So let's go ahead and say light curtain. All right. So what I'm going to want to do then is say that if I'm running a program or I'm in MDI, so if either of those conditions, I'm either doing one of those and that input gets broken, I'm going to set fault, which once I set that other fault, it'll put the system into SV stop. But the other thing too that I'm going to want to do is set my fault message, which means that because I don't have anything defined, I'm going to have to define something. Fault message word, and I'll just pick a name that I'm going to define later. I'll put curtain. Let me keep everything consistent. Curtain. Wow. Running. In this case. Alright. So then, what this is doing is it's now going to, if I'm running a program or I'm in MDI and that input is tripped, so like that, I physically put my hands in there or I do whatever to break that light curtain, I am going to set this other fault memory bits, which once I set that, it's also going to put the system into a SV stop state, and I'm also going to assign this constant into the fault message word value. So like that, I display a message to let the operator know, saying, hey, this is why it faulted. All right. So let's go ahead up now and define this curtain while running message. All right. So go up here. Let's do it message 44. Curtain while running message. And so that is now going to be error code 44. So because I had that, I now have to go ahead and define it in the PLC message file. So let me go ahead, open the PLC message file, which once again is in that CNCM directory. Hold on. That open as a text. Let me say open. All right. So now we got 44. Okay. All right. So now I'm putting a message saying that the light curtain was tripped while running. Basically, that means that hopefully that the operator knows that, all right, well, this thing put into fault because the controls saw that the light curtain was tripped while they were running a job. All right. So let's go ahead. That's good. Save that. All right. Now another thing too that I want to do, I want to make sure that because this is a light curtain, I want to prevent someone from actually running a program while that light curtain is tripped. Now, in order to do that, there's already logic that says do cycle start, and of course that cycle start is how you run a program. What I'm going to do is add another condition to that logic that already exists for do cycle start to make sure that it can't run a program as long as that input is in the correct state. So I'm going to go ahead and search for do cycle start. Okay. And here we go. And this line of logic that pretty much says that, all right, if the cycle start key, which if it was on a physical jog pendant, that's the key that gets pressed, or the keyboard shortcut memory bit to move a cycle start, or this MPG cycle start. That MPG cycle start is a memory bit that's used for the wireless MPG. So if that button was pressed, or this memory bit for the skin cycle starts, that is the memory bit associated with the cycle start button on the virtual control panel. So it's going to be when either of those are pressed, and then I'm going to add another piece of logic that says and. Okay. So when either of those are being pressed, either the memory bits or that physical key, and as long as that light curtain is in the correct state, then it'll perform the cycle start. But if this light curtain is not in the correct state, and one of these buttons or items are being selected or highlighted, this will not run because this is preventing this entire condition from being true. All right. So once I go ahead, do that. So now I pretty much have the logic that I need for the light curtain. Let's go ahead and do this. We'll save that as a file name. And let's go ahead and add this today's. Okay. Save it. Let's go ahead and compile it. Okay. All right, compile it. Now let's go ahead and I'll reboot my system here. Okay. All right. So now we can go ahead and let's look at PLC Detective. Let's search for okay. Now this line of logic right here, if I can run this, well, probably won't run the home sequence on here. Oops, forgot to put this on top. All right, so see if I press cycle start, even though we see that this thing is trying to start it, it physically won't do the cycle start, and that's because my light curtain is not in the correct input. So what I'm going to do is go ahead and flip that switch. All right, now that my light curtain is in the correct state, now when I go ahead and try to start it, it'll actually, oh, I'm sorry, I forgot to reset it. All right, now if I go to hit cycle start, it'll actually try to go ahead and try to actually run the program. Of course, because I have an all-in-one DC, I don't have any motors, there's nothing that it can actually physically do. But it attempted to run it. Now, the one thing that you do end up seeing is that once this light curtain is in the false state, if I go ahead and try to run it, I can't run it, but there is no message on here that shows up that tells me, hey, I can't run the program. Now, the other thing too, because of that, if we had an operator and they try to go run it, and because nothing is popping up, that to me is a bad sign. Anytime you try to prevent something from turning on or preventing any kind of motion, there should always be some type of message that will tell the operator, hey, this is why I'm not, or I'm preventing you from performing that action. Because especially on this is tied basically because of the state of an input. But the operator, all they're trying to do is they're trying to hit cycle start to run it, and they don't know what's going on here because nothing is being, there isn't a message that gets displayed on there. So what I'm going to do is I'm going to have another condition that says if I do this and this thing, my light curtain, is in the incorrect state, then I'm going to say, okay, display this message. So let's go ahead and let's do that. Now the other thing too, I can do is show you in MDI. Okay, and of course I try to move it, try to get into MDI, and it faulted out. This would be the same thing if I was running a program and it just faults out and it tells me that message. And let's go ahead and actually see that in the PLC diagnostic menu. So let me go ahead, put the light curtain in the correct state, bring up that PLC diagnostic menu, and I turn it off. Okay. Right, toggle stay on top. And as you can see, we're going in and we're actually looking at this particular line of logic. I'm going to go in, yep, all right. So we'll go into MDI. Okay, of course, as this, whenever you're in MDI, it's almost essentially the same thing as if you're program running. And because my light curtain, this part of the field is not true, which means that my light curtain input is in the correct state, which means that I haven't broken or tripped the light curtain, I'm not putting the system into a fault state. Everything is good. I see the white block. But let's say if I push my hands in, I trip the light curtain, lo and behold, this then becomes true. I set this other fault, and of course, I assign this constant to the word value for the fault message, which is 11265, and you can see down here that'll display this light curtain trip while running message. But yeah, so as far as that section is actually working perfectly fine. So it's working as intended. The only thing that I'm going to do is I'm going to add some additional line of logic that if they're trying to hit cycle start with the light curtain on, that it displays a message so like that they know, hey, this is what's going on. All right, so now let's go ahead and modify the PLC program. All right, so what I'm essentially going to do is just copy that same line of logic and just say, if that, then I'm not going to do this, but okay. So I am going to go ahead and assign that to that error message file. Now I didn't set the fault message because this is not essentially going to be putting into a default. This is just preventing the cycle start from turning on. So I am going to go ahead and put this thing into that fault message or the error message on here. So like that, it's actually displaying it. Actually, no, let me change that. Rather than doing error message, let me just do info message. Because I don't want to put the system into a fault state. I just want to let the operator know, hey, this is why I'm not turning it on. Because as long as the system isn't going into a fault state, I don't have to cycle the e-stop to clear that fault. All right. So now I just need to go up here and define that current cycle start. And I'm going to use error message 45. Let's do 1, 2. Okay. Save that. Let's go ahead and compile it. Compiled successfully. Let me go ahead and reboot the system here. But remember, I'm also going to have to change the message file. So I'm going to have to add a new message. But while I'm doing that, I might as well restart it. Save some time. So let's go into that and let's add another message. 35. Let's just copy this entire thing. Okay, so we'll just have a message that says light curtain trip while pressing cycle start. Let's also update that. Say while program running. Makes it a little bit more descriptive. All right. So let's go ahead, save that. Now the other thing too to realize, as you can see, and you'll probably end up seeing on there, you don't want to make these messages too long because then they'll end up going over past the screen. Because you'll see that you'll have a few lines on there. But the more messages that you end up having, or the bigger the message, it'll start moving on to the next line down. So let's save that. Let's go ahead and start the software. All right, let's go ahead, open up PLC Detective. All right. All right, clear that fault. Keep forgetting to toggle the thing on. It's like that. We're gonna go ahead and try hitting cycle start. And right now the light curtain is not in the correct state. So if I try hitting cycle start, that should end up bringing this message into here. And as you can see, it's currently set to 0. But the moment that I end up doing that, and I say it actually tells you and shows you light curtain tripped while pressing cycle start. And like I said, because that message was actually kind of long, it actually started importing the stuff into the next line. Okay. So because that it's just a display message, it's not putting anything into a fault state, all I have to do is then flip the switch to make sure that it's in the correct state. Once that's done, now I can go ahead and press cycle start. And of course, you can see that it tried to move the Z-axis because it's trying to home the machine. Because I don't have any motors connected to it, it faulted out. But it tried to run the program. So I can clear it, flip it into the, so like that I tripped it, and then of course if I try to run it, I can't run, but at least now it points and gives me a message that says this is why I can't run. It's because the light curtain was tripped. Okay.